In example 3, we're going to look at other situations where direct substitution fails, but factoring and canceling won't really help us. Let's first take a look at part A. You can see, without really doing any scratch work, that direct substitution fails because putting 0 in place of x will put a 0 in the denominator. So we're going to multiply by the conjugate of the numerator and see what we can do from there. So the limit as x approaches 0, the square root of x plus 1 minus 1 all over x. Multiplying by the conjugate of the numerator, it's going to help us get rid of that radical and see if we can cancel anything. The conjugate of root x plus 1 minus 1 is root x plus 1 plus 1. We'll multiply by the same thing in the numerator and denominator of a fraction, because anything divided by itself is 1. So multiplying by 1 won't change any values. We're just going to make this look different. What we're going to come up with now, oops. Remember that multiplying conjugates results in the difference of two squares. So square the first term, we get x plus 1. Square the second term, we get 1. We'll subtract those, difference of two squares. And we'll have x times the quantity, root x plus 1 in the denominator. Well, right now we can tell that plus 1 and minus 1 eliminate each other. So we've got the limit as x approaches 0 of x over x times the quantity, root x plus 1 plus 1. Now, we can see that the factor of x in the numerator, factor of x in the denominator eliminate each other. And now we got the limit as x approaches 0 of 1 over root x plus 1 plus 1. Finally, after all that algebra work, direct substitution will work. This is going to be 1 over root 0 plus 1 plus 1. Well, 0 plus 1 is 1. Square root of 1 is 1. Plus 1 is 2. So we can say now that the limit as x approaches 0 of our function is 1/2. Okay, now let's go on and take a look at part B. This is a very similar problem. Direct substitution will fail, so we're going to need to do some algebra tricks. Let's get started rationalizing by multiplying by the conjugate. And we'll multiply by root x plus 16 plus 4 over root x plus 16 plus 4. Multiplying by conjugates will result in the difference of two squares. So we get x plus 16 minus 16 all over x times the quantity, root x plus 16 plus 4. Okay, now let's see what we can do. Plus 16 and minus 16 eliminate each other. And we're left with the limit as x approaches 0 of x over x times the quantity, root x plus 16 plus 4. Once again, factor of x in the numerator and denominator eliminate each other. Let's take the limit as x approaches 0 of 1 over root x plus 16 plus 4. Now, direct substitution will work. 0 plus 16 under the radical plus 4. Well, I can do this mentally. Square root of 16 is 4. 4 plus 4 is 8. So the limit as x approaches 0 of f of x is 1/8. Hopefully this video is helpful. Thank you for watching, and good luck on your practice problems.